Hey guys, so this is Miss Morrison. This is 2.7 inverses. In 2.7, an inverse is where you swap the letter X and Y. So when we come up with sets of inverses points, we just swap the numbers. So this -3, 0 will become 0, -3. This 1, 2 will become 2, 1. -4, -5 will become -5, -4. So inverse of points are super easy. You just swap the X's and the Y's. And notice that you take your signs with you. So this -3, 0 became 0. Take the sign with you, -3. If I have a T-chart, the way I find the inverse is still swapping the X's and the Y's. So this 2, 3 is 3, 2. 1, 2 is 2, 1. And 0, 1 is 1, 0. Okay, when we come up with equations, it's a little different. It's a little bit more work. Why don't we look at this part F, this graph? Okay, this is a letter M, and I don't know all the points for sure, but I do know that the inverse of a function is a reflection over the y equals x axis. And the y equals x axis is that diagonal axis that goes through the origin and looks like the line y equals x. So even though I don't have points for this letter M, I can draw the y equals x line, and then I can fold my paper over that line and reflect the picture. So luckily my paper was kind of see-through, so I was able to just fold my paper, trace the letter, and then turn the paper back upside down, and here's my letter that's been reflected over the y equals x axis. So if you have a set of points, you just swap the x and the y and graph it. If you don't have a set of points, like this sucker, you just draw the y equals x line and then draw the reflection over that line. Okay, let's look at these equations. For the equations, we still swap x and y, but first, we don't even have a y on my paper. I have f of x equals x to the third plus 8. So we know that f of x is the letter y. So this is y equals x to the third plus 8. And then the whole point of an inverse is to swap the x and the y. So let's swap the x and the y. We get x equals y to the third plus 8. And then if I want to find the inverse, I already did by swapping the letters, but I just need to clean this equation up by making it look like y equals. So if we're looking at these how-to steps on the tricks I gave you, the first step is to replace f of x with y, and we did it, y. The second step is to swap the letters, and we did it, swap. The third step is to solve for x using SADMAP, unless you have an x in the bottom of a fraction, but I don't have an x in the bottom of a fraction, so let's go ahead and SADMAP. Okay, SADMAP says we either subtract or add first. So if I'm trying to get y by itself, I need to get rid of that tiny 3 in the air and that plus 8. But SADMAP says we need to get rid of the addition first by opposites, so -8 to both sides. And that x and -8 do not actually subtract because they have different butts. They're not like terms. So we get x minus 8 equals y to the 3. So we just did the SA from SADMAP. Now, if we look, I just have a tiny 3 in the air. Well, that's an exponent. And in one of the previous units, we learned that if you have a squared as an exponent, you put a house on it to make it cancel. Same thing here. We have a 3 in the air, so we're going to put a house on it. But that house, instead of being a square root, it's going to be a cube root. So whatever number's in little air goes in your little crook. So since we have a y cubed, we're taking the cube root. When we take the square root, we don't have to put a tiny little 2 in the crook. It's pretend. Okay, so we get cube root x minus 8 equals y. And then the very last step is to show that this is an inverse by using a special notation. So the very last step is to replace the y with f to the negative 1x. That's the special notation. That means inverse. So the very last step is to take that y and put f to the negative 1x. Hey, baby, done with that problem. And we probably could have done this in our face just by thinking aloud. Like if I were to think aloud, I would say the opposite of a +8 is a -8. The opposite of a 3 in the air is a 3 in a crook. The only question is whether the house goes over the x or the 8 or both. So you might have to do the algebra to figure out whether it goes over the x or the 8 or both. Okay, let's look at part D. This says f of x equals 15 over x, and x is not equal to who? Okay, well first, we change this f of x to the letter y. So y equals 15 over x. I have not done anything different. Now we do the inverse part. So the inverse is swapping your x and your y. So now we're going to have x equals 15 over y. Now we SAD map to get the y by itself. But what? Look at that y in the bottom. That we never have that. What? So what we're going to do is we're going to get the y out of the bottom because we're not allowed to have that. I need a big fat y equals, not y underneath a fraction equals. So to move this y from the bottom, the opposite of dividing by y is multiplying by y. Okay, then we get alphabet xy equals 15, and then the y's canceled on this side. Okay, now finish it. We're trying to get y by itself. So this x is multiplying with the y. So the opposite of multiply is divide. So we get y equals 15 over x. What? And then to show that this is the inverse, we're going to put that funky f negative 1 of x equals 15 over x. And that's okay. If you notice, the inverse and the original are exactly the same. That happens every once in a while, and it usually happens when you just have a number over x. The inverse is still a number over x. So this only happens once in a blue moon, and it definitely happens when you have a number over x. Okay, so the other part of the question was x is not equal to who? That means what can you put in the denominator that would make that denominator a 0? Because that would be bad. We would have the 0 on the bottom of a fraction that's undefined. The world explodes. Yeah. So the only number I could put in where this x is to give me a 0 is 0. Yee. So if this would have said like x plus 1 in the denominator, then x would not be equal to negative 1, because negative 1 plus 1 is 0. Okay, let's look at this part E. This one's kind of janky. Yeah. Let's maybe make it crazier. Let's put how about 5x plus 18 over x minus 6. Okay, so this one's going to take some work. There's a trick at the end, but I don't want to show it to you yet. So first, let's replace the f of x with a y. So y equals all this dirty mess. Second, we swap the x and the y. So this y equals is now x equals. All this stuff on the right is still in the same spot, but no more x's. Now we have y's. Okay, so now we have to get y by itself. Well, y's in the bottom, and that's not y by itself. That's y in the wrong spot. So just like on part D, to get rid of that y in the bottom, we multiplied both sides by y. We're going to do the same thing here. We cannot have y in the bottom, so I'm going to multiply both sides by, this time, the whole thing, y minus 6. So on the last problem, I did not have to multiply by a bunch of extra stuff because I just had a y in the bottom, so I multiplied by y. Here, I have y minus 6, so I multiply by y minus 6. Okay, on the right, it cancels. On the left, we're going to distribute. So y times x is alphabet, xy. Negative 6 times x is negative 6x. Equals, on the right, we still have that 5y plus 18. Okay, then we need to get the y's by itself and also together. I have a y on either side of the equation. That doesn't work. I need the y's on one side of the equation and not in the bottom of a fraction. So we got rid of the y in the bottom of a fraction. Now we need to get the y's on the same side of the equation. So this xy, I'm going to leave it there. But this 5y, I'm going to subtract it so that I can put it on the left over here with my xy. So I want everything with a y to be on the left side. Everything that does not have a y goes to the right side. So this minus 6x, it does not have a y, so I'm going to move it to the right side. By oppositing is plus 6x plus 6x. Okay, now let's see what we got. We got xy minus 5y, no more x's, equals, no more y's, 6x plus 18. Okay. Now we're trying to get y by itself. Well, it's with two terms right now. But there's something we can do called a GCF. If you notice, there's a y on both of these terms, so we can take out the y. We can take the y and separate it by taking it to the outside of a set of parentheses. So my GCF, we're going to say is y because it's on both of these suckers. So we get y, open parentheses. What times y gives me xy? X. What multiplies with this y to give me minus 5y? Minus 5. Equals 6x plus 18. Okay, the whole point is to get y by itself. Well, it's pretty darn close. I just have y multiplying with all this big junk of x minus 5. So the opposite of multiply is divide. And then y will be by itself because the x minus 5's cancel. So we get y equals 6x plus 18 over x minus 5. Holy poop. Okay. So let's review what we did. At the very beginning, we changed f of x to the letter y. Then we swapped all the x's and the y's. Then we cannot have a y in the bottom, so we multiplied both sides to get that y minus 6 to cancel away. Okay, then there's no more fraction, and I want y by itself, which means I need y's together on the same side of the equals. So I move this 5y to the left and that 6x to the right, so that now all I have are y's on the left side, everything without a y on the right side. Now that I have y's all on the left side, I take out a GCF of y, so we have y parentheses x minus 5 equals 6x plus 18. Then we finish it off by getting rid of that x minus 5 by dividing. And then our last step is to change that y equals to f to the negative 1x to show us that it's the inverse. Okay, that was a lot of work. The trick, if you want to know the trick, if you compare the inverse with what we just did, they're pretty much the same. The only difference is this 5 and 6 get swapped to 6 and 5. And that always happens if your problem looks like this. With a fraction, an x in the top and the bottom, no x squareds, no x cubes. Okay, let's do another one. Let's say we have f of x equals 7x minus 5. First, we change the f of x to y equals. Then we swap the letters. Then we get y by itself by sad mapping. So we plus 5. And we get x plus 5 equals 7y. Then we divide by 7. And then we can keep it dirty like that for our homework. So we get x plus 5 over 7. And we can keep it crazy. We don't have to change that fraction to 2 different fractions or anything crazy. The only thing is I'm going to finish it off by putting that f to the -1 instead of y. And it's okay that it's on the right side of the equal sign. It's okay. Okay, the last thing that we're going to learn is composition to prove that 2 equations are inverses.